Okay, hello everyone. Today we're going to see the relative position between two lines in two dimensions. So two lines in two dimensions can be parallel or they can be intersecting or they can be coincident, meaning the same line. In the case the lines are parallel, the direction vectors, of course, are parallel. If the lines are intersecting, the direction vectors are not parallel. And of course, if the lines are coincident, the direction vectors are parallel. The system, of course, here will have, since the lines have no points in common, the system will have zero solutions. Here, the system will have one solution, which is, of course, the point of intersection. And here, the system will have infinite solutions since all the points are in common. So first of all, for example, if we have the line xy equals 1 minus 3 plus t 5 minus 2, and another line xy equals 6 minus 4 plus k 10 minus 4. First thing we have to do, of course, is to check and see if the direction vectors are parallel. So as you can see, 5 over 10 is equal to minus 2 over minus 4. That means that the direction vectors are parallel. That means that the lines, if the direction vectors are parallel, are either parallel or coincident. We are going to write a system of equation by equaling the x's and the y's. So the x of the first line is equal to 1 plus 5t. The x of the second line is 6 plus 10k. That's equation 1. The y of the second line, of the first line, is minus 3 minus 2t. And the y of the second line is minus 4 minus 4. Okay, here using elimination, for example, equation 1 times 2 plus equation 2 times 5 will eliminate the t's. So 2 minus 15 is minus 13. 12 minus 20 is 4. Sorry, 8. 12 minus 8. It's 12 minus 20, that's minus 8, and then 20 minus 20 is 0, so the k is also eliminated, and we get that minus 13 is equal to minus 10, which of course is not true, and therefore since the system has no solution, we can conclude that the lines are parallel. For example, if we have the line xy equals 5, 4 plus t minus 1, 3, and the line xy equals 1 minus 2 plus k 2, 12, and we want to find the relative position first, we check to see if the direction vectors are parallel. Minus 1 over 2, as you can see, is not equal to 3 over 12. That means the direction vectors are not parallel. That means that in two dimensions, necessarily the lines intersect. Once again, we write a system of equations equaling the x's. So 5 minus t is the x of the first line, 1 plus 2k is the x of the second line, 4 plus 3t is the y of the first line, and minus 2 plus 12k minus 2 plus 12k is the y of the second line. Then once again using eliminations, for example, the first equation times 3 plus the second equation eliminates the t, so it's 15 plus 4, that is 19. The t is cancelled. This times 3 is 3 minus 2, that is 1. And then this times 3 is 6 plus 12, that is 18. Okay, from here we can see that k is 1. Using that value in equation 1, it's 5 minus t equals 3, and therefore t is 2. So we can see that the system has a unique solution. That means that the lines intersect at a point. To find the point, we plug either k here or t there. Maybe easier to plug 1 here. So if we plug 1 here, we can find the point of intersection. So lines intersect at the point. Plugging here 1 gives 1 plus 2, 3, and minus 2 plus 12, 10. So the line intersects at the point 3, 10. Lastly, if we have, for example, the two lines x, y equals 11, 2 plus t minus 2 minus 3, and the line xy equals 9 minus 1 plus k 4, 6. Once again, first we compare the direction vector. We can see that minus 2 over 4 is equal to minus 3 over 6. That means the direction vectors are parallel. That means that the lines are either the lines are either parallel or coincident. Now we have to write the system of equations. So for example, equation 1, again, equaling dx is 11 minus 2t equals to 9 plus 4k. Equation 2 is 2 minus 3t minus 1 plus 6k. For example, here we'll multiply equation 1 times 3 and subtract equation 2 times 2. That will eliminate the t's, and then it's 33 minus 4, that is 29, and then this times 3 is 27 minus 2, that's also 29, and 12k minus 12k cancel, so here 29 equals 29, which is true always for any value of k or t. Therefore, the system has infinite solutions. That means that the lines are coincident.